Bill, it's up to you now. Convince them that this is the right subject.
Okay, I'll do my best. Thank you, Simone. Number one, it's a real pleasure and honor to be here. I always enjoy coming and visiting Europe and seeing my friends here. I want to tell you something, a confession. 14 years ago, I left data warehousing. Now, most people, when they think of Bill Inmon, think of data warehousing, and indeed, I certainly wrote a lot and talked a lot about it. But about 14 years ago, I began to go off on a different path. And that path was to look across the corporation and look at data that at that time wasn't being looked at or being used. It's kind of interesting, at least it was to me. If you look at the corporation, and you know, it's interesting, people around here talk about data, but the truth of the matter is most people in the IT profession are dealing with a minority of data in the corporation. The truth of the matter is the majority of the data in the corporation is not of the structured transaction variety. And I think it comes as a surprise to a lot of people that work their entire profession only to wake up one day and discover that they've been working out of all of the data, they've only been working on this amount of data. And so I found it to be kind of interesting. What is the challenge? What does it take to get this other data of the corporation into the head of and into management's hands? How can management start to make decisions based on this other data in the corporation? And that led me to some interesting observations. When you start to take a look at this other data, this unstructured data of the corporation, what you find is there's actually a lot of really important data that is being ignored by the corporation today. Let's talk about some of the data that's being ignored by the corporation. One of the obvious places where you find a lot of data that is never used in the decision making of the corporation is email. That it turns out that there's a lot of really useful, valuable information that comes into the corporation in the form of email, and nobody looks at it or uses it for decision making. But that's just the tip of the iceberg. It turns out there's a lot of other really important places where information comes into the corporation, and because that information is in the form of unstructured data, it isn't being used in the corporation. Let me give you a couple of really simple examples. One of the simplest example is corporate contracts. Now, I challenge you to do something. Go to management of a corporation and ask them, do you know what's in your corporate contracts? And I'm going to tell you right now, I have not found one CEO or C-level executive anywhere that knows what's in their corporate contracts. And yet, from a standpoint of liability and a standpoint of obligation, both what your corporation owes somebody else and what somebody owes you, there is a wealth of information in corporate contracts, and nobody knows what's there. And I think that's really amazing. We have these high-paid people in positions of responsibility that don't know the most basic things about their corporation. Why? because it's in the form of unstructured data. But that's just the tip of the iceberg. Let me tell you another one that really gets me, and that is call center information. Most corporations have what's called a call center. What is a call center? It's where somebody calls up the corporation and has a conversation. And so you go to a corporation, you say, do you guys have a call center? Oh, yes. Do you know what's going on in your call center? And it says, oh, yeah, we know what's going on in our call center. We get, on the average, 5,000 calls a day, and the calls are 6.5 minutes. And I say, well, that's an interesting measure of what's going on, but can you tell me about the content of what's going on in your call center? Can you tell me what kind of complaints people have? Can you tell me what kind of questions people have? Can you tell me, do people want to buy something? You know, what is it that's going on in this exchange of information that goes on inside your corporation? Oh, I'm sorry, you can't know that. We can't know that. And the list goes on and on. The most valuable information, the most valuable data in your corporation today, for the most part, is untouched. And why is it untouched? It's untouched because it's in the form of unstructured textual information. And so you say, oh, okay, that's interesting, Bill. Thanks for telling me that. I probably knew that intuitively, but it's nice to hear somebody talk about it. So now that we have looked at the landscape, and now that we understand, you talk about opportunity, you talk about taking a role in your corporation and making a difference in the life and bottom line and success of your corporation. There is no bigger opportunity in front of us than that is presented to us by unstructured data. And I'm going to tell you right now, that's the truth. So let's now talk a little bit about unstructured data. You say, well, gee, Bill, why is it that corporations can't make use of this unstructured data? And there's a lot of reasons for it. One reason is basic database management systems don't fit very well with unstructured data. And that's a valid way of looking at it. But I'm going to tell you something. At the heart of why people can't make sense of unstructured data is something called context. That it's not enough just to look at text. You've also got to be able to look at context. And context is the hard part. And so now context is something that we take for granted. Context is something that in the world of structured systems, it just comes with the infrastructure. So where do we find context in the world of standard everyday systems that we have? We find it in the terms of the definition of records, in the definition of keys, fields, indexes, attributes. Those things all are forms of context. And where does this context come from? It comes from the data model itself. So it's the data model that spawns the context that finds its way into standard relational database management systems. So we said the hard part of this unstructured data world is the whole issue of context. And I've been spending 14 years of my life learning step by step just exactly how hard it is to get your arms around context. So where is context in the world of unstructured data? Context is everywhere but text itself. Context is being in Germany. Context is being in 2015. Context is being you and me as professionals, not children or not elderly people or not people on a playground. Context is being in the daytime, that there's everything in the world, that the environment is context in our world. Now, you say, okay, Bill, thanks, and how is it that you understand what I'm speaking about? How is it you understand a conversation? Whenever you engage in a conversation with somebody, it is assumed that you have context for that conversation to make sense. That's something, again, we take for granted. It's something that is normal, natural, and is part of being a human being. Now let's ask ourselves the question. So the question is, how is it that the computer understands context? And the computer understands context if we have records and keys and attributes and indexes, but what if we just have a long string of data, like an email, or a string of data, like a phone conversation? And the answer is, we don't have context, that in order for the computer to understand context, we need context. And so that's leads us to, you say, oh, okay, Bill, this is kind of I get the drift of what you're saying. How do we get context in this world of unstructured data? Well, we do so with some things called taxonomies and ontologies. And you say, okay, I've heard about taxonomies and ontologies. I'm not really clear what they are, where they came from, and how we use them and whatnot, but I'll take your word for it. So today I want to talk with you about taxonomies and ontologies. Now, I want to tell you before we begin that taxonomies and ontologies are a form of data modeling. If you were to put data vault, taxonomies, third normal form, and Ralph Kimball's dimensional modeling into a room, it would be the moral equivalent of putting cousins of a family in a room. If you've ever been at a family gathering and there are cousins that are in the room together, and you took some time to look at the cousins, what would you notice? You would notice that there is a certain similarity among the cousins in terms of the facial structure, typically in terms of the color of the hair, the color of the skin, the body characteristics. That it's obvious that there's a family resemblance among the cousins that are there at this family gathering. Well, the same thing is true with the modeling that we're going to be talking about. That data modeling, data vault modeling, Ralph Kimball's dimensional modeling, and taxonomies all have a common characteristic. They are recognizably part of the modeling process. At the same time, they are different. Just like if you have 5 or 6 cousins in the room, even though they have a family resemblance, they nevertheless have individual distinctive characteristics as well. And so today I want to introduce you to taxonomies and ontologies. And why do I want to do that? I want to do it because it is a form of data modeling. It's a form of data modeling that's peculiar to unstructured data. It's through the taxonomies and ontologies that we take this stream of unstructured data and turn it from unstructured data into a form of recognizable, understandable information on which we can make business decisions from. So that then is the little conversation I wanted to have. I had originally planned another presentation for the keynote today, but after listening to the other presenters and having conversations at dinner time and over a glass of wine or two, I decided that it would be much more appropriate to have a focused presentation on data modeling for the unstructured world. So what in the world is a taxonomy? Well, the simplest definition of a taxonomy is nothing more than a list of related words. Now, I want to tell you, there's lots of ways relationships can occur, and there's lots of ways words can be related to each other, but we're going to start simple here. So let's take a couple of simple taxonomies. In the United States, we have states called Texas, New Mexico, Arizona, and Utah. There are countries in the world, the USA, Germany, France, Spain, the UK, etc., and so forth. Boys' names, we have Bob, Bill, Dan, Joe, Hans, Steve, etc., and so forth. So these are all simple taxonomies. Now, it doesn't take a genius to say, gee, Bill, if I were to think about it, and I were to think about language, aren't there an almost infinite number of ways of creating related lists of words? And infinite is a large number. I'm not sure infinite is the right number, but for sure there's a lot of ways in which we can create taxonomies. And some of them are going to be appropriate, some of them are not going to be appropriate. And we'll talk about the appropriateness of them. So anyway, that's what a taxonomy is. Then you say, okay, Bill, what's this thing called an ontology? And you say, well, let's take a look at what an ontology is. Here we have countries, USA, England, France, and Spain. And one of our countries, the USA, has states of Texas, New Mexico, Colorado, and Utah. And Colorado, one of the states, has counties known as Douglas County, Larimer County, Jefferson County, etc., and so forth. So we start to see relationships among the taxonomies. Now, there are other definitions of an ontology, but this is Bill Inmon's simple-minded understanding of what an ontology is. It's a taxonomy for which there is a relationship among the words in the taxonomy. Now, with any imagination at all, you can say, gee, Bill, thanks for telling me that a taxonomy may have interrelationships. I think I've seen this before in the world of computers, and I think I saw this a long time ago in something called a bill of material. And I think that if I'm not mistaken, it's very easy to get in an infinite loop. That I can have one piece of data pointing over here, another piece of data pointing back over here, and if I don't be careful with my programming, I sit there and have a program that chases its tail. I go here to here to here to here to here to here to here, and I never finish. And if you made that observation, you're absolutely correct. One of the difficulties of trying to process taxonomies and ontologies is being constantly aware of the fact that if you're not careful, you can fall into some insidious traps. And this is one of those traps. There are some other traps that are out there as well, but I'm just going to point this one out as we go through. So that's what a taxonomy is, that's what an ontology is, and you say, gee, Bill, thanks for telling me that. How does that relate to my unstructured data? What do I do with my ontology, and why does it gives me an opportunity. Well, over here I have something called ICD 9-21. This would be a classification of medical information. That would be my taxonomy. And I have some raw text, and I'm reading the raw text. And when I find in the raw text one of my terms, I give it a higher level classification. So from a mechanical standpoint, this is how I relate my taxonomy to my raw text. And you're going to say, gee, Bill, that's kind of interesting. What good does that do me? Well, what good it does for you is this is one of the ways, not the only way, but this is one of the ways that unstructured data can indeed have context applied to it. Now, while we're on the subject, I want to go off on a tangent that I hope you find to be useful and interesting. You may find it interesting to know that there is a medical taxonomy that exists in the world. There's an organization that has built a medical taxonomy, and if you're looking for a medical taxonomy, you should at least knock on the door of this medical organization. The organization is called Mayo Clinic, and Mayo Clinic has over the years built, I believe it is the world's largest taxonomy of medical procedures and terms that exist. Now, it has been 10 years since I talked with Mayo Clinic, but 10 years ago, Mayo Clinic was offering to organizations that needed a medical taxonomy to have this taxonomy for free. Now, having stated that, I don't work for Mayo Clinic. It's been 10 years since I've talked with them. I have no idea what their stance is today, but once upon a time, Mayo Clinic was offering free access to their taxonomy, which, if you happen to be in the world of medicine, is a real, let me tell you something, at the very least, if you're looking for a taxonomy for medicine, you should go and knock on the door of Mayo Clinic. Now, let me tell you a little second thing about taxonomies. How long did it take Mayo Clinic to build this medical taxonomy? I don't know if you've ever looked at medical terms before, but there are a lot of medical terms and a lot of strange sounding terms in the world of medicine. And just for your information, it took Mayo Clinic 30 years, and they estimate 300 doctors worked on the taxonomy. Now, they didn't work full time. They had their duties they attended to, and they were working physicians, so they didn't have a dedicated 300 people, 30 years. But even with those numbers, you can say, gee, that means that building a taxonomy of this size and scope is a tremendous undertaking. And because eventually, when we end up here, you're going to say, gee, Bill, how do I get my hands on a taxonomy? And that's going to be one of the questions you have. And we'll talk about that. That's a fair question. Anyway, that's a little side issue here. Here we're showing that we have a taxonomy. Here we're showing that we have raw text. We look at the raw text we're processing. If we find the term we're processing in our taxonomy, then we classify it. And that's not the only way, but that is one important way in which we get context for unstructured information. This, by the way, is a form of data modeling. And where does the data modeling come in? Data modeling comes in where we end up taking the creation of the taxonomy itself. So, and again, this is not the kind of data modeling you've probably been used to, but it is a form of data modeling. It's a cousin to the kinds of data modeling that you have come to know and love over the years. So we find out that there's all kinds of complications that can occur. Once you start to use your imagination, you're going to say, wait a minute, Bill, I'm doing medical classification, but within the world of medical classifications, there are hierarchies of information. I can find out that an ICD 9-21 infarction is actually an ICD 187 something else. And the world of classifications, this is just the first inkling that, gee, Bill, this can be a complex world. Because among other things, not only can there be recursive relationships in the taxonomy, there can be multiple subsets and higher supersets of the taxonomy that we need to look at as well. And again, I'm simply putting this in here as a cautionary flag. I'm going to simply say that the world of taxonomies is a world unto itself. It's its own technology and its own world. So how does all of this occur? You say, gee, Bill, this is kind of interesting. How do I take raw text and apply these taxonomies to it? Well, there is technology out there. You may or may not have heard about it. It's called textual ETL or textual disambiguation. And it's technology that allows you to read unstructured information and put it into a standard relational database that can be analyzed. And part of the input into the world of textual ETL is the world of taxonomies, that the taxonomies become a form of input that we put into the technology that allows us to read our emails, read our corporate contracts, read our call center conversations, and put them into a standard relational database that then allows us to do analytical processing on unstructured data. By the way, the ability to do analytical processing on unstructured data is a really, really valuable thing to do. And I want to tell you a little story. I come from a background of being a technician. I've been in technology all my life. And for a number of years, we would talk to technicians about the ability to transform textual information into a database. And over again, the technicians of the world go, come back next year. We didn't do it this way last year. I don't know why my organization would be interested in that. And the technicians of the world just don't get it. And I hope you're not in that class. And so what we decided was that, gee, we're tired of getting turned down by every technician that doesn't understand the business of their corporation. We're going to just sell directly to the business people of the corporation. And I'm happy to report to you that sales, the minute that we decided to stop even talking to the technicians of the world and start talking to the business people of the world, solving business problems, as if by magic, we started making money. And I might add, a lot of money. And so, and again, I feel really bad about this because I come from a technical background, but trying to talk to technicians about vision and opportunity and understanding how to improve their business, I'm sorry, we tried for a number of years and got absolutely nowhere. So we find then that the taxonomy is the means by which, is the data modeling means by which we put structure into the unstructured world. And in doing so, starts to be able to do analytical processing, important analytical processing on the unstructured data of the world. Now, there is something you run across as you're going through all of this. And this is something that is intuitive once you think about it, but most people haven't thought about it. And that is, when you take a look at text, there's really two kinds of text that are out there. There's non-predictable text and there is predictable text. What, pray tell, is non-predictable text? Non-predictable text is text that is random, such as an email. That anybody in the world that writes an email sits there and writes, and you can write anything you want in an email in any order that you want. And so that's an example of non-predictable text. What, pray tell, is predictable text? Predictable text is text that is predictable, such as corporate contracts. Corporate lawyers have something called boilerplate. And what is boilerplate? Boilerplate says that when a corporation starts to engage customers, they create a master contract so that every time their salesman goes out and makes a sale, they merely fill in the blank. And every now and then, somebody will want to negotiate a term or two, but at the end of the day, 99% of the contracts that are out there are in the same predictable form. Another form of predictable text occurs in real estate documents. That when the counties of the world record a real estate transaction, they do so in a very uniform fashion. Another form of predictable text are medical laboratory results. Let me give you an example. A quick example is blood pressure. Whenever you see blood pressure recorded, and I assume it's the same in Germany, but it's diastolic over systolic. It is never systolic over diastolic. And so when you're reading laboratory results from a medical report and you see blood pressure, you know just from the form of what you're looking at what is what in the form. It's very predictable what is placed in the right place. And this is true not just of blood pressure, but a lot of other measurements that occur in the medical laboratory as well. So we find then that when we start to look at taxonomies and ontologies and ontologies apply to non-predictable text. They don't really apply to predictable text. From a mechanical standpoint, we see that the raw text, he ran his Porsche at over 80 miles an hour. We go examine our taxonomy. We find the word Porsche is identified as a car, and then the car comes along, and that's how we place that in our database. So the car becomes the contextualization of the Porsche. And where does the car come from? It comes from the taxonomy, which is a form of data modeling. Now, what does this contextualization allow us to do? One of the things it allows us to do is to do queries. Now we can start to do queries on the raw text, except that in this case we can look for a car. Note that a car was never in the text itself, yet we can still do queries on it. This then, from an architectural standpoint, is how things are put together. The raw text comes in many different forms: OCR, optical character recognition, voice character recognition, through documents themselves. We pass them through the taxonomies and ontologies, and then the result is a relational database whose source is unstructured data. Once we've created the relational database whose source is unstructured data, we can now come along and do analytical processing. We can use Tableau, we can use ClickView, we can use SAS Institute, we can use Excel spreadsheets. There's 100 different ways to sit here and do our analytical processing. The architect chooses which tax. Okay, now here is one of the subtle points, and we want to spend some time on this. You're going to say, wait a minute, Bill, we started off by saying there are an almost infinite number of taxonomies. Would I ever use all of those taxonomies as input into my textual disambiguation process? And the answer is no, I wouldn't. For example, if I were doing an analytical processing for General Motors, I most likely would choose taxonomies that would relate to bill of materials, parts, manufacturing process, etc. I wouldn't probably choose taxonomies that relate to ethics, morals, contracts management, chemical engineering, airlines, etc., and so forth. So I would choose a set of taxonomies to process against that are relevant to and focused on the data that I have to process. And that's another aspect of the whole process of contextualization and data modeling. Now let me talk about something. You say, gee, Bill, this taxonomy stuff, can't this get to be complex? And we've already seen that. Yes, indeed, it can be complex. You say, well, now, wait a minute. I'm reading some raw text about a Porsche. He ran his Porsche at over 80 miles per hour, and we've identified that Porsche is a car, but isn't it true that Porsche can also be a German product? Yeah, if that's what I'm looking for, I can have Porsche be any number of things. It can be a sports car, it can be a German product, it can be a luxury item that you stop and think about it. Porsche can actually be lots of different things, legitimately. And so this is where the art of data modeling and the art of contextualizing your textual data starts to come into play. We're pointing out in this little slide that there can be recursive relationships, and let me tell you, anytime there can be recursive relationships in data, you as a programmer are warned you better be careful, because if you're not careful, you can end up being in an infinite loop, and when you go into an infinite loop, nasty things happen to you in your program. Another concept that we have with taxonomies is, on occasion, we want to create what's called a preferred taxonomy. That as we are starting to disambiguate our text and contextualize our text, on occasion we want to say, okay, this taxonomy is preferred over all other taxonomies. And can we do that? Absolutely, we can do that, and it makes sense to do so. On occasion. Again, it's just something that we can do if needed. I'd like to point out that at the point of granularity of how this all looks to the system, at the end of the day, every taxonomy can be broken down into a series of parent-child relationships that at the most granular level, a large taxonomy with all kinds of hierarchical relationships can ultimately be transformed into a series of simple parent-child relationships. And why is that important? From a standpoint of doing processing, from a standpoint of writing a program to do all of this, at the moment of doing your processing, at any moment in time, all you're looking at is a simple parent-child relationship. Okay, now an interesting question comes. It says, gee, Bill, thanks for telling me all this. This is really kind of interesting. Where do I get my taxonomies? You know, you're telling me that I need to do all of this. It's like, where do I get my data models? Well, let me tell you where you can get taxonomies. As I mentioned, in the world of medicine and healthcare, there is at least one major taxonomy that Bill Inmon has seen it with his own eyes and has touched it and felt it. It exists. I don't work for Mayo Clinic, and I don't make arrangements for them, but I know that it exists. It's out there. I have heard through the rumor mill. I was doing a class like this one time, and somebody ran up to me and said, gee, Bill, we have a taxonomy for the oil and gas industry. And so now, have I seen it? Have I touched it? Please classify this as a rumor. No, I have not seen it, I haven't touched it, but I have had people tell me of the existence of oil and gas taxonomies. One alternative is to look across different industries and see if the industry happens to have a taxonomy. And if you're lucky, then you'll find something. A second alternative is to look on the internet. And let me tell you, now this requires some work and this requires some ingenuity, but if you look on the internet for a thesaurus, a thesaurus can be used to create very quickly and efficiently your own taxonomies. So now, having stated that, is a taxonomy the same thing as a thesaurus? No. It requires a little bit of using your brain and saying, well, that's not what I want, or yes, that is what I want. Here's where you as a data modeler have got to do what you need to do. But a thesaurus is a good place to look. A third place to look is the vendor of this technology that we're talking about. And I know because we've been doing this for a number of years now, we have built up our own library of taxonomies. We typically have things like sentiment and other taxonomies that we can just plug in. A fourth source of taxonomies, and you may be surprised to find this, you can look it up on the internet, but there are companies out there that will commercially sell you taxonomies. And then the fifth choice, which we really don't recommend, but it's always a choice, is you can sit down with pencil and paper and create your own. And that's like saying, gee, guys, you want to do data modeling? If worse comes to worse, you can sit down and create your own data model. If you can't find Lynn Silverston's data model, if you can't find an industry data model, if you can't find a vendor data model for you, then of course you can always create it on your own. But given the amount of work that it takes to create taxonomies, that last choice of doing it by yourself is one that we recommend, Boy, I'll tell you, on the few occasions I've seen people try to do it on their own, I sit there and I grit my teeth because I know what's going to happen. It's going to take them 6 months to do it, and ultimately, the problem is most people are not professional taxonomy builders in the first place. And so even if you do try to make it on your own, it's still going to be an amateurish effort. However, can always be done, but please exhaust all of the other possibilities. So that's where you can get your taxonomies from. Okay, that's a little bit then about a world that is a data modeling world. It's as you go forward looking into the world of unstructured data, you go into this world of taxonomies and ontologies. And so should you want to find more information, there are some white papers we have that are free. We don't charge anything for them. You can look on the website forestrimtech.com. There's a bunch of free white papers that are there, and that's another source for information. So I'm now going to look at my clock. It looks like we have a few minutes and time for questions. If anybody has some questions.
I actually have one.
Okay.
So what role do you find in an organization is most involved in building the taxonomies? Is it a business analyst? Is it an architect? Is it a modeler? Somebody from the business
Steve?
side?
I'm going to tell you right now, it's the business person that it's been. I'm going to tell you, over and over, we've gone into corporations and talked to them about processing their unstructured data, and the IT organization just is not doing it. And so we find that it's the end user organization, and it's some poor soul that's given to us by the end user organization. So it's, and now you say, gee, Bill, can't we do better than that? Should it be that way? No, it shouldn't be that way, but that's the way it is.
Okay, thank you. Question here. I think Dan and then here.
Hi, Bill. How do business glossaries contribute to the building of taxonomies, or can they?
Business glossaries are a wealth of information, and when you get lost in building and working with taxonomies, your business glossary becomes an excellent checkpoint to make sure you've done what you need to do. Now, most business glossaries are not taxonomies, although they may have some taxonomical information in there. Again, there is a certain amount of intelligence that's required to create that taxonomy, but a business glossary is your best friend.
Bill, one question. What about business users don't understand the structured data? Should they already start thinking about unstructured data? Because a lot of customers, I see that they are struggling with their structured data current. So isn't the unstructured data one step ahead?
If your customer is struggling with their structured data modeling, send them to this conference.
Thank you, Bill. Thank you.
That's where to go. The conversation I've given you today applies only to unstructured data. For your classical structured data, that's really a different world.
So, as I started my professional career as an information scientist and a kind of librarian, where are these guys? In libraries and documentation centers, they always had built taxonomy thesauruses and such kind. Why aren't they in that place?
These people are doing something interesting. They have polished their resumes up. They're working in Silicon Valley. Just the other day, a friend of mine got hired in Silicon Valley as a data scientist. And what do you think his starting salary was? I'll tell you, his starting salary was $250,000 a year. And to me, I don't know about you, but to me, $250,000 a year is a colossal salary. I will say this much. If you try to buy a home in Silicon Valley, you need $250,000 a year. But and that's no joke. But nevertheless, the people that are turned in. There's this young lady. A friend of mine has got a daughter that's a freshman in college. And last year she came up to me and she says, "What should I take as I start to go to my college career?" And I said, "Ma'am," I said, "you want to make money and be successful when you get out, become a data scientist. Learn everything you can about data science because people are paying ridiculous amounts of money for data scientists." So anyway, that's where they all went. They're in Silicon Valley, living in mansions, and so that's what happened to them. I'm saying that tongue-in-cheek. I'm not really saying that in tongue-in-cheek. I really did have a friend of mine that went to Silicon Valley and made $250,000 a year. They're paying ridiculous salaries in Silicon Valley for data scientists and information management people.
The question I have is me. How do you deal with...
I'm sorry.
Here.
Okay.
How do you deal with languages and translation in taxonomy?
Okay, you asked the question, I'll give you an answer. The technology, textual disambiguation that I'm referring to, currently works in romantic-based languages. That means it works in English, Portuguese, Spanish, German, French, Italian, and there's one more we work in, and Dutch. What we don't work in are the Oriental languages, and we don't work in Mandarin, Kanji, or Korean. Now, most people think the problem with the Oriental languages is what's called the double byte problem, because Oriental languages require 2 bytes of description rather than 1 byte description of what we're used to. That's not the problem at all. Let me give you a quick little diatribe of a conversation I had. I happened to be on an airplane the other day with a friend of mine named George. George is from Shanghai, and George was reading something in Mandarin. And I don't know if you ever, have you ever seen Mandarin? Mandarin is a block of pictures. And so I asked George, I said, "George, let me ask you a question. When you're reading this, how do you know where one word starts and the other word stops?" And George looked at me kind of strange, and he said, "You just know. That's part of reading Chinese." And I said, "Okay, let me ask you the question differently. How does the computer know that where one word begins?" You see, in the English language, we're kind of spoiled, because in the English language, we have a space or a punctuation mark. And whenever we get to a space or a punctuation mark, we know we finished a word. It's not true in the Oriental languages. In the Oriental languages, it's all run together. So the way the Oriental languages do it is they take the Chinese language and divide it up into different dictionaries. There's one dictionary for 10 picture words. There's another dictionary for 9 picture words. Another dictionary for 8 picture words. And so forth and so on. So how they process a block of Chinese text is they come along and they say, "Well, is this a 10-picture word? No. Is it a 9-picture word? No. Is it an 8-picture word? Yes, it is. Aha, we know what it is. Go to the next word. Is it and there's this parsing process through the different Chinese dictionaries. Now, with a little imagination, you're going to say, gee, Bill, doesn't that chew up machine cycles in a computer? And the answer is I really can't think of a process that chews up more machine cycles. You talk about something that just, sucks up the electricity in the room. Trying to read and parse the Chinese languages is a feat unto itself. So anyway, currently, the way things work, the Romantic-based languages, that is English, Dutch, French, German, Spanish, Portuguese, Italian, those languages are all easy. Now, I have a friend of mine, I do, by the way, I speak English and I speak Spanish, but I don't speak any other languages. I have a friend of mine who's Arabic, and he says that the technology that we have will work easily with Arabic. And he's a very knowledgeable person. Have we done it? No. But I'm told on good authority that we should be able to do Arabic as well. So that's a little bit about different languages.
Any other questions? Okay. Thank you, Bill.
Thank you so much.